Good morning, class. Now we continue this part, area between the curve and the straight line. Look at page 102. Area between the straight line and the curve. So look at this example. So the shaded region shown in 3.1a is the region between the curve. So this is the curve between the curve and the straight line y equals to fx from x equals to a to x equals to b. So this area of shaded region, how we're going to find this? So if you previously recall back, you only learn how to find area under the curve. So only one curve or one straight line. So now is involving one straight line and one curve. So how to find it? You will do like this. So we look at what is above. What is at above? So in this case, how we know above or below? Remember the x-axis or the y-axis always is the floor. So this is the floor, meaning that this part will be above. So in this case, curve is at above. So we're using curve minus straight line. Curve minus straight line. So why is it curve minus straight line can get this shaded region? So you imagine if you integrate the curve from A to B with respect to x-axis, you will get this blue color. And then the straight line, if you integrate the straight line, you will get this one. If you integrate the straight line from A to B with respect to x-axis, you will get this red color. So blue color minus the red color, meaning that the curve minus the straight line, you will get this shaded region. So illustrated by this diagram. The area under the curve minus the area under the straight line, you will get this shaded region. So we can make conclusion. Area of the shaded region is integrate A to B for the curve minus integrate A to B for the straight line. So above minus below. So look at this, another one more example. This one is straight line, this one is curve. How to find this area of shaded region? So remember the x-axis is the floor. So who is above? Straight line is above. So if I integrate this straight line from A to B with the x-axis, so I will obtain this trapezium like this. So area of this trapezium minus the area of under the curve. So this is the curve, and then from x equals to A to x equals to B with respect to x-axis. So the red color minus the blue color, you will get this shaded region like this. So for these cases, above is straight line minus the curve. So you will get the shaded region. Let's look at example 18 at page 102. So this diagram at the right show the curve. So this curve with this equation intersect the straight line y equals to x plus 2 at these 2 points. So find the area of this shaded region. So remember how to find area for this shaded region. So x-axis is the floor. So who is above? So meaning that from here we can see that curve is at above. So to get this shaded region, remember where is the A and B? So A is at -2, and then the B will be at here 3. So A and B, if you integrate the curve, you get this blue color. And then if you integrate the straight line, this straight line, integrate the straight line from this -2 until 3, you will get the red color. So the blue color minus the red color, you will get the shaded region. So from here we can make conclusion, curve minus straight line. So you will start to do integrate for the curve. So integrate, curve 1 is integrate from -2 to 3. Remember, smaller at the bottom, bigger at the above. And then dx. For this one, because it's x-axis, so dx, here you need to substitute y. So y is curve. So curve is minus x squared plus 2x plus 8. So this is curve. So minus the straight line. Okay, for the straight line, you can choose integration as well. So integrate -2 to 3 dx. So the straight line equation is x plus 2. This is first method. If you don't want to use integration to find this area of triangle, actually you also can use the area of triangle formula to find it. So this part, Okay, I explain the first method first. You use the integration. If you use integration, how you're going to do? These two you can integrate straight away, or you combine like this first. Because the value from A to B is the same, then you can combine. If these two value is different, then cannot combine. So because this one is the same, so we combine. It will be easier for you later on. So minus x minus 2, simplify, getting this. Then you do integration like usual. Negative copy, x copy, power plus 1, divide the power 3, plus x copy, power plus 1 become power 2, divide the 2, plus 6x. From negative 2 to 3. Then you build the bracket. So next step, you need to build the bracket. Negative bracket power 3 over 3 plus bracket power 2 over 2 plus 6 bracket, and then minus. Negative bracket power 3 over 3 plus bracket power 2 over 2 plus 6 bracket. So substitute. After build the bracket, substitute the value is 3 and negative 2. So 3, 3, 3, negative 2, negative 2, negative 2. So key in calculator at this stage. After key in terms of x, press the button, calculate. Key in 3 equal, key in negative 2 equal, and then press the answer, what minus what, and get a final answer, 125 over 6. So remember this part. This is the first method. Second method that I'm going to show you is like this. This one remain the same. The only thing changes is this part. This part, actually, you can choose, because you see, look at this diagram. Actually, area under the straight line sometimes can be triangle, sometimes can be rectangle, sometimes can be trapezium. So you can use the basic formula of trapezium, triangle, and so on to find this part. So this part, example, this one is triangle, right? So I know this height is 5, right? So I can use 5 here. And then this length is, the base is, here have 2, here have 3, so the base is 5. So I can use 1 over 2, 5 times 5 to replace this part. So that one is the second method. So up to you. You want to use back the basic formula of triangle, or you want to use this integration, up to you. It's okay. So look at example 19. So the diagram on the right show the straight line. So this straight line and the curve intersect at these two coordinates. Calculate the shaded region bounded by the line and the curve. So you need to calculate this shaded region. So from this diagram, we see when you have involving one straight line and one curve, so what you need to know is what is at above. So usually we use above minus below. If the shaded region is what we call like tergantung, okay, tergantung, does not stick with the x-axis, then you can use this method. So x-axis is the floor. So the one above is the straight line. So the one above is the straight line. So for these cases, we use straight line minus the one below is curve. So how to use straight line? If you integrate straight line from this point to this point, you will get this blue color, right? And then if we integrate the curve, from this point to this point with respect to x-axis, so we'll get this red color. So blue color minus the red color, you can get this shaded region, which is requested by the question. So now the problems come. How you know what is these 2 points, these 2 coordinates? So what you need to do is, well, notice that actually these 2 points is the intersection point between the curve and the straight line. So how to find intersection point? You just solve it simultaneously. So just use substitution. For these cases, it will be easier if you substitute the y in, because you need the x value, right? If you need the x value, meaning that you need to everything in terms of x, so you need to sub the y. So y equals, so let the equals, substitute in, and then everything move to left hand side. Over 2, you just multiply 2, multiply 2, multiply 2, multiply 2 for each of the term until you get this quadratic equation. Then next part, you just solve the quadratic equation by using factorization. Just press mod 53 until we get these 2 values. One is negative 2, one is 3. So logical thinking, this point will be negative 2, this point will be 3. So how to integrate this one? So similar like just now, this part, blue color, actually area under the straight line actually is a trapezium, right? So you can choose either using integration like this, or you use the trapezium area formula. So up to you. If let's say you want to use integration, so how you do integration? You will do integrate, because now you already know straight line minus curve. So straight line integrate from -2 to 3. So dx here, meaning that here you substitute y. So y is, for straight line is 1 over 2x plus 6 dx. So this is the straight line. Minus area under the curve, do the same thing, integrate -2 to 3 for dx. So here you substitute the y for the curve. Okay, so this is the first method. How to do integration? Just do like usual. So this one combine first, and then combine this number, can combine together, become 3. Then do integration for this part. So how to do integration? Number copy, x copy, power plus 1, divide power. And then plus 1 over 2 copy, x copy, power plus 1, divide the power. Plus 3 become 3x. So this one, you can key in calculator, 1 over 2 divide 2, you will get 1 over 4. This one, 1 over 2 divide 3, you will get 1 over 6. And this one just copy down. So next step, just substitute like usual and you obtain the answer. So how we're going to, okay, I will show to you if I want to use the area of trapezium to replace this part. So how I'm going to show, how I'm going to do it. So I'll show you now. You can also use the basic trapezium formula to solve this question. By changing this integration become area of trapezium. So now look at your trapezium. How we're going to know this height is what? You just substitute x equals to -2, put inside here. So you will have what? 1 over 2, -2 plus 6. So we have -1 plus 6. So that point is 5. So meaning that this height is 5. And then for this height, do the same thing, substitute 3. X equals to 3 plus 6. So you have 3 over 2 plus 6. Okay, from here, 3 over 2 plus 6 actually is 15 over 2. So 15 over 2. So equivalent 15 over 2. Meaning that this height is 15 over 2. So you can use the formula of trapezium, area trapezium, parallel side plus together 5 plus 15 over 2 multiplied by the height. Height here is 2 plus 3, so 5. You equal, you key in this one, you should be able getting same answer for this part. So up to you, you want to do integration for both like this, or you want to choose the basic formula for the area for that one. Okay, next example 20 will be area between two curves. So what happens if you have two curves? So now you have two curves, one is this, one is this. Intersect at 1, 1 here. So and 0, 0. Find the area between two curves. So this one actually is same also. So x-axis is the floor. So now you can see the area from here until this point 1. So who is above? The one above is this one, meaning that curve number 1 minus curve number 2. So curve 1 minus curve 2. Curve 1 is the one above, you will get the one blue color. If you integrate curve 2, curve number 2, from 0 to 1, you will get this red color. So blue color minus red color getting the shaded region that you want. So curve number 1. So how to integrate curve number 1? It will be integrate. The point is 0 to 1. Here is dx. So this one substitute y. For curve number 1, y is this. And then minus curve number 2 is the one red color. Do the same thing, integrate 0 to 1, x squared dx. So these two just combine and then you do integration like usual until you get 5 over 12. So today your homework will be 3.6, exercises 3.6, 2BC, and then try to do question number 3. Just now, okay, what I discussed all is with respect to x-axis. What happened for this question C? I think I need to discuss with you also. Actually, for x and y is the same, same method to do. So for these cases, okay, I will explain in the other video.